One of the greatest challenges of grid shell design is to iterate different options rapidly. It's impossible to know immediately if a given design will work or fail, so the ability to rapidly modify the design and see the outcomes is a big advantage. The great thing about using Grasshopper as a design tool is that I can make basic changes to the shape or other parameters and see the result immediately. When I was researching grid shell design, I noticed that most of the structures were symmetrical and open on the sides, which is the most basic way to design grid shells. However, I wanted to make sure my design was able to be adapted to best fulfill my design needs. After the form finding, I added a part to my Grasshopper script that allows me to create openings in the structure. Next, I made a basic program, or list of the main spaces and features I wanted to include in my design. Then I tested some forms to see which would work best for my structure. Since I wanted 2 sleeping areas, I thought a triangular perimeter would work well to have the sleeping areas on either side. However, it seemed that a more circular perimeter led to more efficient space use, as more of the structure was above head height. In the end, I went for a combination which worked well for my needs. Once I had the basic form, I drew up a plan. As you can see, I have a main room that opens up onto a deck outside. I have a stove in the back of the room that forms the focus of the space. This will also allow the structure to be used year-round. I have 2 sleeping rooms on the sides, with bunks around the edge. Once I figured out the basic form and program of the structure, I still had to make a few more decisions. These actually had to do more with the structural analysis, which I will cover in a different video, but I will explain them now. One of these was the spacing of the lath grid. After the structural analysis, we saw that the structure was so efficient that any spacing less than 2.5 feet was sufficient. However, when the laths were spaced more than 1.5 feet, the form finding made the perimeter more square in shape and the height of the structure decreased. So we decided to keep it at 1.5 feet. Originally, we also weren't sure whether to make the structure with a single layer of laths or a double layer. However, we decided to go with the double layer because it allows a massive increase in the overall strength of the structure with only a little more difficulty bending. For each design decision in this project, it was at least as much work to think of the right questions to ask as it was to answer them. Allow me to end this video with a quote from Buckminster Fuller. "A problem adequately stated is a problem solved theoretically and immediately, and therefore subsequently to be solved realistically."